Welcome dear students in the second video of this refraction through a lens. In this I am going to explain about formation of image by a lens. To find the position, size and nature of the image of an object formed by a lens, we have to first we need to consider at least two rays starting from a point on the object, and this can be taken from certain rules. That means the rays chosen are those for which the path after refraction from the lens is known to us. So let us see some rules for the refracted rays, from which direction, on which direction they will go after refraction. The first one, a ray of light incident at the optical center of the lens passes undeviated through the lens. See, the ray of light incident on the optical center, it passes undeviated. In this also, convex also and concave also. The second rule is, a ray of light incident parallel to the principal axis of the lens after refraction passes through the second focus or appears to come from the second focus. Let us see. In this, parallel to the principal axis after refraction actually passes through the focus, and in this parallel to principal axis it diverges, so it appears to diverge from the focus. So always in this case. Third we can see, if a ray of light is incident along the focus or directed along the focus, after refraction it becomes parallel to the principal axis. So these are the three rules which we will use to determine the position, size and nature of the object, nature of the image formed by a lens in case of concave and convex. So now let us see where will be the image formed. The image is formed at a point where the refracted rays actually intersect after refraction or appears to diverge from that point. So to draw the ray diagram, at least two rays we will choose from these, and at the point where they intersect after refraction, there will be the image formed. If they intersect after the refraction actually, then the image formed is real, and if they appears to diverge from a point after refraction, then the image formed is virtual. So we can say the image is formed at a point where the refracted rays actually intersect or appears to diverge after refraction. There are two types of images, real image and virtual image. So real image is formed at a point where the refracted rays actually intersect, and virtual image is formed at a point from where the refracted rays appears to diverge. Real image is always inverted, and real image can be obtained on the screen, but the virtual image cannot be obtained on the screen, and virtual image is always erect. So these are the some rules. Let us see the image formation first by convex and then by concave. Let us see the characteristics and the location of image formed by a convex lens. The first case, when the object is at infinity. When the object is at infinity, the rays seems to be coming parallel to the principal axis, and they converges. When the rays of light comes parallel to the principal axis, after refraction they converges at the focus on the other side. So image is formed on the other side of the lens at focus. The size of the image is very small, that is highly diminished, and the nature of image is real and inverted. So we can say the position of the object is at infinity, the position of the image is at focus on the other side of the lens, nature real and inverted, and this size very small, highly diminished. In this manner, the lens is used as a burning glass, as it converges all the rays of light at a point. So we can use this as a burning glass. So it is the application of this manner of image formation. Next, second one, when the object is, in this also I show, when the object is kept at infinity or at a very far distance from the lens, then also the rays of light seems to be incident parallel on the lens, and the image is formed at the focus. It is not a point size image, the image is formed at the focal plane. Focal plane is a plane which is passing through the focus and perpendicular to the principal axis. So the image is formed at the focus. So we can say the position of object is at very far from or infinite or very far from the lens. The position of image is at focus. Nature of the image is real and inverted, and size of the image is also very small, that is highly diminished. This is also the same application. Now we can see the second position, that is when the object is placed beyond the center of curvature. The image is formed on the other side of the lens between focus and center of curvature. The nature of the image is real, inverted, and the size of the image is smaller than the size of the object. In this manner, the convex lens is used as camera lens. This is used as burning glass, this is used as camera lens. So application is this, but in camera lens we use this. Next one, third, we can see when the object is placed at the center of curvature, the image is formed on the other side of the lens at center of curvature. The size of the image is equal to the size of the object. The nature of the image is real and inverted. In this manner, the convex lens is used in terrestrial telescope. Next, we can see the fourth position, when the object is placed between center of curvature and focus. When the object is placed between center of curvature and focus, the image is formed on the other side of the lens beyond the center of curvature. beyond the center of curvature. The nature of the image is real and inverted. In this, the size of the image is magnified, means larger than the size of the object. This type of, in this manner, the lens is used as a slide projector to form a large image. Next one is when the object is placed at the focus of the convex lens, then the image is formed at infinity on the other side of the lens. The nature of the image will be real and inverted. In this case, the image is formed which is highly magnified. In this manner, the lens is used as a collimator to obtain the parallel rays of light. The last case, when the object is placed between focus and optical center, the image is formed on the same side, and this image is virtual and erect, which is known as upright image. This image is highly magnified. In this manner, the lens is used in magnifying glasses. So these are the 6 positions of object and their locations of the image. In all the first 5, the nature of the image is real and inverted. Only when the object is placed in between focus and optical center, the image obtained is virtual and upright. So this is about the image formation by convex lens. Let us see the characteristics and location of images for a concave lens. When the object is at infinity, the rays comes parallel, incident parallel to the principal axis on the lens. After this, the rays of light diverges and it appears to diverge from a point F, that is focus. So the image is formed at focus. The image will be highly diminished, and as I said, the rays of light is not actually intersect, they appears to diverge from the point F2, so the image is virtual and erect. So we can say when the object is at infinity, the image formed on the same side the image formed on the same side of the lens as the object. That means this side object, this side image is also same side, and it is virtual and upright. The size is very small, which is called highly diminished. A concave lens is used in Galilean telescope in this manner. This is also the same if the rays of light is not parallel to the principal axis, then also one ray we saw which passes through the optical center without deviating, as I said in the rules, and one ray becomes parallel to principal axis. When we produce it in the backward direction, it appears to meet at focus. So same position is that. Next one is when the object is at finite distance from the concave lens, means the object is placed between infinity and optical center. In this case, the position of the image is in between the focus and optical center on the same side of the lens. We can see the object AB, the image formed is A dash B dash. The image formed is A dash B dash, which is also on the same side as the object, and the image is virtual and erect, as this is also seems to be diverged from these 2 points. This a concave lens is used in specs for the myopic eyes, myopia, which is a type of defect in the eye. So the last position what I said, if the object is placed between infinite and optical center, the image is formed between the focus and the optical center of the lens on the same side. The image formed is virtual and upright, the size is diminished. Thank you students, thank you for watching.